Hi everyone, my name is Richard, and I like dinosaurs. Usually when I give a talk, I wear a pair of my lucky dinosaur socks. Unfortunately, I'm moving at home and they're at the bottom of some box, and so I just have to wear plain socks today. So if this talk sucks, now you know why. I don't have any lucky dinosaur socks, but to prove that I actually do this, here's a picture from a previous droidCon. I'm a developer evangelist. That's my job, and I think actually that's kind of the coolest job in tech. I live in Berlin, and one of the cool things about being a developer evangelist is you get to travel a lot, right? So a couple of times a month, they send the signal out over Berlin. I get on an airplane, and I get to go to some cool and interesting place. Just for droidCons alone this year, I've been to New York, I've been to Tel Aviv, I've been to London, and now I get to be in San Francisco where the air is clean and everything is perfect. I think that's awesome. I love travel, I love getting around. It's kind of a big privilege of this job to do this. And sometimes when I go to events, I get to combine those two things. I get to travel somewhere, and then I go and get to look at dinosaurs. So conference in Chicago, have some couple of hours of time between the conference and the flight. Well, off to the Field Museum I am looking at Sue. I was doing a hackathon last year in Singapore, and the food there is great, but otherwise it's mostly just malls, and I was kind of a little bored and had to fill a whole day, and then I realized, oh my God, there's dinosaurs there. I get excited, what can I say? So I was at droidCon New York earlier in the year, and what did I do afterwards? Of course, I went to the American Museum of Natural History, and they had just put up this awesome new Patagotitan skeleton, which is like the biggest dinosaur in the world. So that's kind of cool. And when I do that, I usually literally just have like a couple of hours between checking out of my hotel and having to be at the airport to go back home. So in order to get from where I am, my hotel or the conference venue at the end of it to the dinosaurs, I usually use some sort of ride-hailing, ride-sharing, whatever you want to call it, app. Like I'm generally speaking a big fan of walking. I'm generally speaking a big fan of public transit. But one of the really cool and magical things about this kind of app is you pull your phone out of your pocket, you push a button, and somebody comes, picks you up where you are, and drops you off where you want to go. And you don't really even have to think about where you are, how to get there. It all just kind of sort of happens automatically. And that kind of magic is really something we've almost started taking for granted. Just the very notion of being able to grab and go into your pocket, pull out your phone, and immediately know where you are. Right? If you think about it, there's a whole generation that's now grown up that doesn't even know the feeling of being lost anymore. Because it used to be a long time ago, not that long actually, but let's say it's a long time ago, it used to be that when you were lost, you were kind of lost. Like you had to maybe ask someone, or you'd have to look at the trees and see which way the moss is growing, and then, right? These days, you just grab out your phone, and there's a little dot on your phone that tells you exactly where you are. And we sort of take that for granted, even though, of course, there's a lot of technology underneath it, right? There's satellites involved. There's like a massive database of places and addresses and the map, and all of that has to be collected and created and curated. And you need fancy algorithms that actually figure out what is the route in given traffic conditions, and considering that the train is late. There's a lot of technology in there. So. And ride-hailing apps are really a particularly cool example of this, because they sort of throw up a lot of the questions that this type of technology is built to answer. So it throws up the question, where am I? It throws up the question, where do I want to go? It throws up the question, how do I get there? It throws up the question, how long does it take to get there? Can I get there? What's around me? Who's nearby? All these kind of questions that need to be answered for an app like that to work. And that's kind of what I want to do in this talk. I kind of want to go and say, how does that actually work? How do they do that? So what I want to do is I want to take like a ride-sharing app and kind of deconstruct it into its individual pieces and kind of look under the hood and see what kind of data is underneath there, what kind of technology is underneath there, what kind of APIs are there that answer those questions, And so at the end of this, hopefully you'll have gotten kind of a nice overview of sort of location technology, of sort of the basic APIs involved in this, and hopefully also an idea of how you can use them in your own applications, be they ride-sharing applications or anything really relating to location and technology, which these days is a lot. Like I said, my name is Richard. I'm a developer evangelist. I work for a company called Here Technologies. And we are the world's leading location technology company. As examples, I'm going to be using our APIs in this, though the general concepts apply really across the whole industry. If you do want to know more about us, we have a developer portal, developer.here.com, which is where you can find all of the APIs I'm going to be using today. We also have a booth out there on the floor, so if you want to know more about the company, about what we do, we can come out there afterwards. I'll be hanging out there. I've got some nice colleagues. I've got Nick, who's hiding there in the corner, my colleague. He's waving. So you can come and talk to us. You can also follow us on Twitter. If you like people who are really bad at social media, you can also follow me on Twitter. That's really up to you. I wouldn't, but hey. So let's look at how an app like that actually looks like. So this is sort of a generic version of a ride-hailing app, right? And you've got all these various elements. You've got a map. You've got that little green dot that tells you where you are. You've got maybe sort of little icons showing you kind of what drivers are nearby. You've got a little box that asks you where you want to go. There might be like a little box that shows you like the address of your current pickup location so that you can figure out where you are if you're in the right place for someone to pick you up. There might be a button at the bottom to actually call a ride once you've decided where you want to go. So these are kind of the elements you have sort of across most of these applications. And I really want to take a look at every single one of those elements and figure out how they work. And I'm going to start with this one, the little dot, right? Kind of the most important thing, because that really throws up and answers the question, where am I? Because if you don't know where you are, nobody can come pick you up, and the whole thing already stops right there. And it's really kind of a foundational thing for anything involving location, because if you don't know where you are or a thing is, or where where anything is, if you don't have a location, none of this makes sense. You'll see all of the APIs I'll be using later. At some point, they'll always want a location as an input. So if we don't have that little dot, we can stop right there. So how do you get that little green dot? Well, how do you get your position? You use something called a positioning API. And using that is actually pretty easy, at least to start with. So in our Android SDK that we have, there's a class called Positioning Manager. And you get an instance of that. You start that, throw in a parameter or two. And then you can just say, hey, Positioning Manager, get position. And what it gives you back then has two functions called get latitude and get longitude. And when I do this, and when I look at that location string, when I look at what actually shows up after I do this, it's this. Actually, it's not this, because this is the example from droidCon in New York that I'm using. So the idea is I want to go to the American Museum of Natural History from droidCon in New York. So this would be the address in New York. If I did this here, it would look like this. This is not immediately helpful. This is just two very long numbers. And to understand what they mean and to have a rough idea of how to interpret them, we kind of got to look at something like this, right? So if we are at 37.76 something, comma, minus 122.393 something, what does that actually mean? Well, it's a fairly complicated subject, but I'll try to give you a rough overview, right? Back in the day when people were like, oh, wouldn't it be nice to know where you are in the world? They basically thought, well, okay, we can sort of do some sort of grid system with two coordinates, and then you can use those two coordinates and you can figure out where they are. The main problem with that is that inconveniently the Earth is round, despite what they say on YouTube. And so they couldn't quite use like a standard Cartesian rectangular grid system. So what they did is they drew two lines around the world. One around the middle of the world, which is what we call the equator, and one which starts at the North Pole, ends at the South Pole, and goes inexplicably through Greenwich in London. There's lots of stories about people fighting about where that should go through, and if, of course, the French really didn't like that it went through London, but eventually they agreed to do it anyway. So if you've ever been to Greenwich in London, this line is called the Prime Meridian, and you can actually physically visit it in Greenwich in London. It's like a whole UNESCO World Heritage Site, the area, so it's kind of a big deal. And with the equator, they just started drawing parallel lines up and down the Earth and just started counting them until they were at the North Pole, and then they said this is 90 and started counting them down until they were at the South Pole and until it was minus 90. And in fact, if you've ever heard someone say, oh, such and such thing is at such and such parallel, that's literally what they're talking about. They're just saying how far north or south is it on the Earth. And then and so that's the latitude number. And then you have the longitude number. They didn't do parallels there. They kept drawing lines that start in the North Pole and the South Pole. And again, they started kind of counting towards the east up to 180 until you're on the other side of the world, and counting down up to minus 180 when you're again on the other side of the world. And when you have that sort of rough notion, looking at that number at the top, the 37, minus 122, starts making a little more sense. Because in California here, we're sort of in the northern hemisphere, sort of roughly, but not quite halfway up the Earth. So that number sort of makes sense. And I actually flew here through London, through Heathrow, and it was like a 10-hour flight almost. So minus 122, that kind of makes sense, right? We've got, I actually had to go a lot west quite a bit before I got here. Not quite to the other side of the Earth, but quite a bit. And again, if you look at the number for the Expo Center in Brooklyn, where the droidCon in New York was, still sort of kind of makes sense, right? It's a little bit, it's roughly like 4037 is roughly the same way up the Earth, but it's a much shorter flight from London to get there as you're heading west, so you're only at minus 73. So that's kind of neat. We have a rough idea, at least, of what those numbers mean. Another interesting question would be, where do those numbers actually come from? Like, how does our Android SDK know these numbers? What did you say? Satellites, yeah. So actually that's a good answer, because most people will say GPS, which isn't wrong, but isn't the whole picture, right? Sure, there's GPS, but there's also, which is the US system, but there's also GLONASS, which is the Russian system, which is Galileo. That's the European system. The Chinese are putting their own system up, like in India, they're putting at least a partial system up that kind of covers the subcontinent. The Japanese have put some satellites up that augment GPS to make it work better over Japan. And all those systems collectively are known as GNSS, Global Navigation Satellite System. And many devices these days actually support multiple of these things. Like even my watch here, that supports GPS, GLONASS, and Galileo. So you can combine these kind of things. And even that isn't the whole story, because you can often get a position when you're in a building. And if you've ever used a system that just uses GPS, you'll realize, as soon as you've got some concrete over you, you can't see the satellite signals anymore. It doesn't work. So there are other ways of doing it. And again, I could fill like a whole 45 minutes just on this. So I'll just say you can also do this on with radio signals. So you can see cell towers and you can see Wi-Fi access points. And if you have a database and you know where those are, then you can sort of triangulate your position. That has some advantages in that it also tends to work indoors, where you can still see the cell phone signals, but it is a lot less precise. In practice, you usually do like a fused approach, where you take as much positioning information as you can and then use a positioning API like this that gives you the best guess based on all the various things that you have. Okay, cool. So we've got this little dot there. But staring, and we roughly know what that number means, but staring at that little dot, that still doesn't really tell us where we are. Because the power of a latitude and longitude in many ways is that it gives you that it allows you to put yourself in a context. And in many ways, that context is a map. As soon as you have that little dot, not just as a number or just on the screen by itself, as soon as you have it on a map, now you start to actually understand where you are. You have the context of a map around. And how do I get a map? Well, with something like an imaginatively called thing like Maps APIs. I don't actually want to throw like code up here because getting a Maps API working is mostly just really boring boilerplate code. You know, you import some libraries and you create a map object and that's kind of it. So I kind of want to talk about something else, which is that making maps is hard, like super, super hard. We make maps as a company, so I should know. Like we have thousands of people all over the world collecting map data every day. We've got like a couple of hundred LiDAR cars that collect 30 terabytes every day, and that's still really not enough. This is a Dutch map from the 16th century. I don't think they had LiDAR back then. And you can sort of see, this is supposed to be a map of New Guinea. You can see there at the bottom in Latin it says Nova Guinea forma et situs, which basically means like shape and location, which is cool, except that that's not how New Guinea is shaped, and it's also not where it is. I've looked at this for a long time, and this part here is supposed to be New Guinea. Those islands in the middle are supposed to be the Solomon Islands. Again, not what the Solomon Islands look like, also not where they are. You can also see that sort of at the north side, the north coast of New Guinea, the cartographer is a lot more confident about how that looks like, whereas on the south side, he's like, yeah, I guess there's a coastline. Haven't really been there, don't know. And then at the bottom, the big thing that's supposed to be Australia, and at that point, you can just see the poor guy just throwing his Dutch hands up in the air and just going, here be dragons. It's gotten a little easier since back then, but it's still really hard. So it's kind of important to consider the source of your map data, the quality of your map data, and there's never like an easy answer to which one is the best. It really depends on your use case, but it also depends on what I awkwardly call the use place, because some maps may be really great in San Francisco, but that doesn't mean they're great everywhere else. So you really have to consider where do you actually want to offer your service, right? And check for map coverage and map quality there. Maps are super complicated. For example, maps are super political. So this is a map of the same place, but it's a different map. It's slightly over-compressed the image, but maybe you can see where the difference is. So this is the southern tip of South America. You've got Chile to the west, Argentina to the right, sort of the Patagonia, Tierra del Fuego area down there. And there is a little difference in those maps, and it is up here. So this map is fairly confident that it really knows where the border between Chile and Argentina is, and the other one is like, there's sort of an area where I don't know. And one of those, and I forgot which, but one of those is the Chilean way of looking at the border, and the other is the Argentinian way of looking at the border. Basically, one of them is quite sure that the border goes that way, and the other one is like, we haven't really hashed this out, you guys. I think we need to talk about this more. So I've picked this because it is not one of the more explosive border disputes in the world. But you know, when I gave a kind of a similar version of that talk in Tel Aviv, I didn't really need to explain to people down there the power of maps and how borders can be tricky, right? And you can get in trouble for this if you get it wrong. So it's always something to keep in mind when working with maps, that these things are involved in that. And there's another thing, which is, of course, a map isn't a map. Like a map can look radically different, and you need to design the maps, the look of your maps and its features for what you're actually going to use them for, right? So on the left, you've got like 3 buildings, and it's a little 3D buildings, and it's tilted a little bit, and you've got the famous bridge there, which with some textures on it to make it look cooler, but it's not really helpful to read where you are on the street if you want someone a ride to go pick you up. And then the one on the right is kind of designed to be looked at night and really highlights public transit lines. So again, maybe not ideal for a ride-hailing app, but maybe cool if you want to see where the subways are all going. And you can change these things usually quite easily. So again, it's an example from our Android SDK, and I've sort of tried to come up with a way to make a map that's completely useless for everyone. So I've basically centered it somewhere on New York, and I've set like a weird map scheme which is designed for night use and highlights transit lines, but it's also hybrid in that it both shows roads and satellite imagery, and then I set the landmarks visible, and then I zoomed in to close and tilted it by 45 degrees, and I got this monstrosity. So when working with maps, it's always a good idea to get designers involved and to consider what your use case is. So for our use case, a simple, clear-to-read map is probably not a bad idea. Highlight the roads, highlight street names, maybe throw in some landmarks. You know, it's always nice for someone to see, oh, I'm across from that Starbucks. I can see that on the map. This is actually where I am. I can confidently call a ride because I know they'll be able to pick me up here. Another way to answer that question, where am I? And you'll note we're still 20 minutes in, we're still at where am I? And it tells you something about how important location is to all of this. Is you have this little thing that shows you your street address. Again, that's super useful because it helps you orient yourself, right? We talked about location earlier with GPS. It's not always super reliable, particularly if you're, say, in New York and maybe the GPS signal gets bounced off buildings or maybe it gets blocked by buildings and you've got like the fairly large circle around your location where you might be. So you've got to orient yourself a little bit with the help of the map. And one nice way of doing it is to just show your street address where you want to be picked up, because that's the actual address that will then be sent to the driver. And it's a nice way to figure out if you are actually where the app thinks you are. There's just a little problem with that. We got a latitude and longitude out of our positioning API. We don't actually have a street address, right? So how do we get that? How do we get our street address? Well, this is where an API called, less obviously, a geocoder API comes into play. So this is an API that essentially will convert addresses from geo-coordinates, latitude, longitudes, to street coordinates, your street address. So simple example here, what a geocoder does, it'll take your street address, so 72 Noble Street, where the convention center in Brooklyn is, and it'll turn that into that latitude, longitude that we saw earlier. Obviously, that's something that might be helpful to the post office as all of those packages come in and they want to know where to actually send their delivery people. What we want is reverse geocoding, which takes a latitude and longitude and actually converts that into a street address. So this is where the droidCon was in Tel Aviv. It was actually in a cinema, which is kind of a cool location to give a talk. So you'll actually see 32 something, 34 something. You think about where Israel is on a map, sort of again, northern half, a little bit further south than here, a little bit east of London, kind of makes sense. And then you can take that and using the geocoder API, which is essentially powered by a large database of all addresses in the world, and you can turn that into a street address. And then you can take that and display that to the user. And again, code-wise, that's not very complicated. You kind of define your pickup location like a geocoordinate, and then you create a reverse geocoder request object. Then there's a little result listener that'll get called when you once the API's got your result, and then there's a location object in there, and from that you can just get address, and it'll give you that as a string. Obviously, there's a lot more information in there than just an address string, and you can also pick out the individual elements of an address, just the street name and the street number maybe, because the user will probably know they're in the US, they'll probably know they're in New York. All they really want is just the street name and the street number, so you can pick that out, format it any way you like. Cool, so the next thing that we want to show is kind of the drivers around us, right? So you usually have this kind of thing where it'll show you lots of drivers on the road, none of which are actually willing to take your ride, but it gives you huge confidence that somebody will pick you up in 2 minutes, and then it's like, your driver will arrive in 12 minutes, and I'm like, nah. But nevertheless, you got to figure out where those drivers are, not the very least, because eventually someone will have to accept the ride, and you want to pick someone who's close by. So you got to figure out where the drivers are. Well, fortunately, we've already answered that question, right? We have a positioning API. And that works on their phones just as it works on our phones, and they'll just send it to the back end and you can display it on our phones. So that one's easy, we've already got that covered. So let's look at another more interesting element of the app that we looked at earlier. We're finally gone from where am I, where is everyone? We can now go to another where question, which is where am I going? Well, when droidCon New York was over, what did I want to do? I wanted to go to the American Museum of Natural History so I could look at some dinosaurs. And the American Museum of Natural History is at 200 Central Park West. So what I can do is I can enter that into the little box at the top into that text field. And then what happens usually is it'll give me options, right? It won't just take what I type in and be happy with it. It'll actually show me a list of things that it thinks it sort of match the string I've put in. So it'll give me, for that example, I've tested this, it would get me 200 Central Park West, but it'll also be like, maybe you meant Central Park South, or maybe you meant Central Park North, and it also went like, well, there's like a Central Avenue very close by, maybe that's what you meant, right? And we make typos a lot, so this is actually super useful. So how do you do this? Well, for this, you can go back to that geocoder database of all the addresses in the world, except this time you use it slightly differently, and you use a geocoder autocomplete API. So what you do into this API, you feed a partial address string, and it goes through that database and gives you addresses that match this or that are close to it. I'm going to throw up a REST API example here for once, partially because I want to highlight all of this stuff is not just available through Android SDKs. You can obviously use that everywhere you want. Like I've mentioned this watch earlier. I've built some apps with using REST APIs for my watch here, which is not an Android Wear device, by the way. It's a Garmin watch. But it's also REST APIs are sometimes a little easier to look at the parameters you put in, so it's slightly easier to explain. So you've got your API endpoint like autocomplete.geocoder something. Then of course you need some credentials, which you can get on our developer portal, and then you put in a query. So in this case, 200. I put in 200 Central Park. I left the West out because 200 Central Park is definitely an incomplete address, and that's kind of what we want to test. And then what you can do with the next parameter is you can sort of limit your search area. You obviously don't want to search the entire world for addresses that match 200 Central Park. You kind of want to search addresses nearby. And there's various ways you can do this. In this particular case, I've put in a proximity parameter. So I'll say, this is where I am. Please search for things in a radius of 3 kilometers around me. You can do it with bounding boxes and along all kinds of different parameters. This is a very simple way of doing it. And then when we look at the JSON response that comes back, you get this list of suggestions, and each of those suggestions will have address information in there, right? So it'll have a label. So that's a simple way. If you just want to display the complete address, you can grab just that. But it'll really break the address down into each of its individual elements, and then you can maybe just pick the house number and maybe just the street name and the postal code or something, and format it in a way that's useful to your user. What's also interesting is the match level you see there. Let's say we hadn't put in the 200. I would have just put in a Central Park West. Then he would have found a street for me, but he wouldn't have found an exact house. So this would not have said house number. It would have said, I think, street or something, because that's about as precise as it would be able to go. And if you put in something like Manhattan, it would have put in just district, right, as the match level. So that's also something to always consider when you're doing this. Of course, I've sort of cheated right now, because when I was going to the American Museum of Natural History, I would not have put in 200 Central Park West, right? Because I have no idea what the address of the American Museum of Natural History is, and nobody who ever went to the American Museum of Natural History knew what the address was, because they weren't going to an address, they were going to a place, right? You're going to the museum. Like if you're asking someone in the street where the museum is, you're not asking where's 200 Central Park West. So what I'm actually searching for is for a museum. So I kind of need to do the same thing, but not for addresses, but I need to do it for places. So for example, I want to put in American Museum off, and then I want to stop because I'm lazy and I just wanted to show me the result. And if you do that, it does. There's apparently a lot of American museums in New York. Kind of like Museum of the American Gangsters sounds kind of interesting. I think I want to go there next time I'm in New York. So how do you do this? Well, in the same way that there's a database of every address in the world, there's also a database of every place in the world, and you can access that through a Places API, right? So you would do this, again, it's not super complicated, you would define kind of a search request, you would put in a a partial search string. You would again say, please search near this coordinate, because you obviously don't want to search the entire world for American museums off. You want to just search New York. So you can put like a search center in there. You can say how many results do you want. In our case, like the UI allows for 5, so we'll pick 5. And then you can execute that. And again, there's a listener that waits until it gets the response. And then at the end, you basically get like a list of discovery results. And each of these discovery results has like a place link item. And in that place link item is the information that you're looking for, the name of the place, but there's actually a lot of information in there. There is the name of the place, there's the address of the place, there's the geo coordinates of the place, but also things like how long is it open, right? You could do smart things in your app, and if somebody says, hey, I want to go to the American Museum of Natural History, you could say, well, it's closed today. Are you sure you want to go there? Do you just want to hang out in front, take a picture, or do you want to go inside, maybe pick something else? So my plan actually for Wednesday, which is tomorrow, was to go to the MoMA. My hotel is literally in the same building, and because I'm very smart, it's closed on Wednesdays. So got to find some other place, some other activity I can do indoors before my flight leaves in the evening. There's also ratings in there, Yelp ratings and all kinds of things. So you can do interesting stuff with that, not just show somebody the nearest Starbucks, but the best Starbucks that's in walking distance, those kind of things. Cool. So assume we've done that. We've shown the results. You can, of course, also cleverly combine the two and show results from both properly ordered in your app. I tap on this. I tap on American Museum of Natural History, because that's where I want to go, because that's where the dinosaurs are. So I tap on this, and then what happens? Well, usually what it'll do, it'll draw a route on the map. And it'll also give me some other information like, based on car and traffic, that'll take 28 minutes to get you there. It'll, might give you an estimate of how much it costs to do this, depending on how the ride-sharing thing works. It might be vague, it might be very precise. And then the question is, right, how does it find that route? How does it figure out how much it costs? How does it figure out how long that takes to get there? And that's what a routing API does, right? Based on the map data we have, which for roads is basically a giant complicated graph, you can then do, like we all learned in our computer science classes that we may or may not have taken and may or may not have attended, you can do like, shortest paths and graphs and all that kind of stuff on that. And that's what a routing algorithm, routing API does for you. So simple example, again, using our Android API, you basically create a router object, and then you create a route plan. And that route plan just has waypoints. In our case, it's pretty simple. We've got 2 waypoints. We've got our start waypoint at droidCon. We've got our end waypoint, which is completely wrong, because obviously the American Museum of Natural History is not at 49 minus 123. So actually, I'd be curious if somebody could look up what that address is, whatever the heck I put in there. Let's just pretend it is the geo coordinate of the American Museum of Natural History. And so you have a start point and an end point. You can obviously put a lot of those in there. You can, if you're a delivery service, you can put all the 25 delivery points that you have for your packages in there and get a route there. But in our case, we just have 2 waypoints, so that's nice and easy. You also create some route options. You'll see that we were setting a transport mode to car, which makes sense because it's a ride-hailing app. But you could also set it to, hey, I want to walk. I actually like walking. Maybe not in this smoke, but otherwise I like walking. You could do public transit. You could do like motor scooters, and you could do bike and all these kind of things. So there's a lot of options you could set there. In our case, car works, which is kind of the default. You also kind of need to set a route type. In our case, we set fastest, but there are other options, including you can say, I really want the shortest route in traffic. That's rarely a good idea, so we'll go with fastest. We want to get there as fast as possible because we do have a plane to catch later on. And then all you really do, I should have gone through these slides where I highlight the things I'm explaining, but I didn't. And then again, there's like a listener, and I get a result, and from that I can get a route. And in our Android SDK, very nicely, you can just literally just grab a map route out of there, and it's immediately a drawable object. So you just add it to the map, and it'll immediately draw it on the map, which is very nice and convenient. But you can also get like each individual latitude and longitude point for the whole route and manually draw things, style them the way you want to. And in order to figure out how far away it is, how long it takes, there's information in there. So in this case, I'm saying get length, which tells me how long that route is in, let's say, miles. And for example, if my ride-sharing app charges by mile, I could then multiply that with my mile cost, and that's how I know how much it costs. I could also get the time out of it, and then it would tell me how long it takes to get there. So this would be the result you would get if you use the REST API. Let's look at sort of the JSON response that you would have to parse manually if you did this, and you'll see there's a lot more stuff in there, right? So I got the length, which I've just queried. I've got the travel time in seconds, so I can show how long it takes. And then I got this list of maneuvers. So really what the routing algorithm gives me is the entire route on the way, every single step I need to take to get from A to B, including these nice verbal instructions. So it'll literally, if I wanted to, I could build my own turn-by-turn navigation for the driver. We're looking at the passenger app here, but if we wanted to build the driver app, we could use this to build turn-by-turn instructions for the driver. Literally says head towards West Street on Noble Street, go for 79 meters. And that would take you 15 seconds, and it would be 79 meters long. You can also, I mean, I'm German, so I like proper like metric stuff, but you can also do that in whatever you use here, right? There's a parameter on the API for that as well, right? And it gives you this, and then it tells you the next step, latitude and longitude, where you would end up, and then it says turn right on West Street and so on. So there's a lot of information in there that you can grab out. So we feel like, okay, 28 minutes is fine. We accept the price. Now we're finally ready to hit that button and to call us a ride. Right? So we're putting this, and what happens then? The app says finding nearby drivers. And suddenly all those 500 drivers that were really close to us just around the corner magically disappear, and he has big trouble finding drivers. And obviously, how do you do this, right? So here's a map, here's where I am. An obvious way to do this would be to just draw a circle around it with like maybe 2-3 kilometers, miles, whatever around me, and then just go, hey, which drivers are in there, right? And then send the request to them. Whoever pushes the button first gets the ride. Like various services have different ways how drivers bid for this, but let's use that as an example. You can immediately see what the problem is, right? One of those two can actually get to us pretty quickly, and one of them definitely can. He's on the other side of a river, he's not close to a bridge, and even if he is close to a bridge, everyone who's ever been stuck in a ride on one of those interminable bridges knows that it takes a long time to get across them. So is there a smarter way? Yes, there's many ways to do this and to address this. One of them, which I really like, is called an isoline routing API. What that actually does is it says, hey, isoline routing API, show me all the places in the world from which I can be reached within 5 minutes of driving. And then if you draw this on a map, it looks kind of like this, right? So I got this shape on the map, and every driver that is within that blue area can actually reach me within 5 minutes. And first thing you'll notice, anyone who's in Manhattan, not a chance, right? It's not going to happen. But you'll also notice that down here, if someone's already on the interstate heading in my direction, they can actually be a little further away and could still get to me in time. So that's kind of a really nice, smart way of figuring out which drivers are around you. This is a cool API. You can use that for other ways as well. You could flip that around, and you could say, what can I reach from my position? And here we've done it with time, but you could also do it with distance. So let's say your EV says, I've got 20 miles left of charge. You can basically say, hey, which areas can I reach in 20 miles of driving? And you can show the driver only those EV charging stations the driver can actually still reach with the charge he's got left. So he doesn't get stuck in traffic on a bridge and then he runs out of charge, because that's super embarrassing. Not that it ever happened to me. So this is, again, a REST API example. You've got your app ID and app code, and you can see, again, you can set the mode like with the routing API. You can see there's a traffic enabled thing. This is actually really cool. If you do this for a city in the morning, it'll be tiny. And then if you do it in the middle of the night, it'll be huge. And you can really see that thing, this area growing and shrinking throughout the day based on kind of commute times, how many people are commuting in and out of the city. So there's some people who've built kind of like these city heartbeat animations based on those APIs. It's really kind of cool. So in our case, we want to set like a destination, which is where we are. We want to set a range and a range type. So in this case, we've set a range of 6,000 and a range type of time. So I've talked about 5 minutes, but this is 6,000 seconds, so that's 10 minutes, right? So anyone who can reach us in 10 minutes would be within the result that I get from this API. Okay, we're running out of time for this talk, but the good news is we're closing in on the end. Really, all we have left now is we've clicked the button, we've found a nearby driver, they've accepted the ride, they've come to us, they've picked us up, we're sitting in the back, we're looking forward to the dinosaurs, and all we really do at this point is occasionally look at the app to make sure the driver isn't cheating us. So we can see this, see where we are, we can see the route to the museum, we can see how long it is until we get there. And well, we've done all that, right? We've got the positioning API to find out where we are. We've got the routing API to draw the route, to figure out how long it is. We have to call that occasionally to refresh that. And that's really all there is to it. So from the passenger perspective, we've gone through all of the things. And that means I can now go to the dinosaurs, which, by the way, you should not let me do that because I'm extremely clumsy. And I'm not even joking, I went on vacation in Bhutan, which was very nice. And there was a museum, and I bumped into one of the cabinets, and one of the priceless national treasures literally just fell off the plinth. And I was like, okay, I'm going to get arrested. But they were very chill about it. It was very cool. I really appreciate this. They were very nice to me. Don't let me near your dinosaurs, but please let me near your dinosaurs. So time's up. Thank you for riding with me. I know this was at most a 3-star talk. The room wasn't that clean, everything, but I really need to stay on the platform. I really need to keep riding, and I want to keep flying around the world giving talks about dinosaurs. So please give me 5 stars. And now we have like a couple of minutes left for questions. Thank you. Okay, so the question was, how do you actually convert a latitude and longitude to an address? The answer is, it's just a huge database. Like, we have a database of every address in the world, and we have a location associated with every address in the world. Of course, you structure this cleverly, and if you look at an address, it's already structured, and then you come up with like clever database engineering to make sure it's efficient and you get fast responses. But in the end of the world, when I said making maps is hard, I wasn't kidding, because you literally have to build a database with every address in the world. And since those things change all the time, you have to keep that updated and updated and updated and updated, and it's hard work.
Sometimes when we come across issues like it's not able to fetch the location or response time out when we are doing that. So how do we how do we handle this kind of situation? Because if we are making this app, we have to be sure that we have to do a good user experience. So what is this thing on that?
So I think the question was about sort of the unreliable nature of like a positioning API. And this goes back to what I said. I could talk 45 minutes just about positioning, because it's A, so important, and also B, so annoying. Like all those issues you have with ride-hailing apps where it's like, your driver is coming in 5 minutes. I was kidding, it's 20. No, he's here, it's 3 minutes, is because of imprecise positioning, right? The driver goes into a tunnel, suddenly you have no idea where they are. Or in New York, you have this issue, lots of very tall buildings. Like half of the satellites are blocked. The 3 satellites you can get, they're bouncing off a building. And the truth is there's no easy answer for this, right? This is why you still have these issues in these apps, because there are physical limitations to these kind of systems. Like if you do it with the wireless signals, you have a much better chance of getting a position, but it's not very precise. With GPS, you can get a fairly precise location, but it's often unreliable if you're close to a building, if you're under trees, all these kind of things. So there are clever things you can do. For example, there's an API which is called a route match API, which will actually snap your position to the closest road. So even though the driver's GPS signal may bounce around a bit, you can always show them in the middle of the road. And then you just have to do things like interpolation, like dead reckoning, right? Which is what those apps do too. Like they'll show the car driving along the road, even though they lost the signal like 10 seconds ago. They have no idea where they are, but he's probably still on the road, so I'll keep driving him along. And most of the time, you'll get the signal again, and it's just sort of, you just have to move it a little bit faster, and then it's caught up again. And sometimes you end up in that situation where, no, he actually took a right turn, he's somewhere completely different, and then it's like you end up in that situation where it's oh no, he's much further away than we thought. You can do clever things like that. You can do some caching, some smoothing, some interpolation. But if you don't have a location, or the location you have is wrong, there's not much you can do. Again, like you can remove outliers. If he suddenly jumps like 200 meters to the north, you can probably go, that's probably not right. So you'll don't show that on the map. There's a whole bunch of these tricks you can do and you can use, but it's not. Ultimately, there are limits to it, and we experience those limits every time we use these apps. I think you had a question first.
How is breadcrumbs on a map engineered? Because I wonder, like, the driver always needs to broadcast his current position to some server, right? But we don't always want to do that because it's going to be very taxing. So, like, I would imagine that's some kind of rate limited put request going on. And on the user side, when he's seeing that, like, is the user just subscribe to listen to like these location update events in order for me to like draw the breadcrumb and move the car along? Like, how does it work from both the driver and the passenger perspective?
The question was, how does that actually work? That the driver sends his information up, and how do you make it so you don't have to permanently send the information and suck up a lot of battery and use a lot of data? And how is it displayed to the user? There's always a trade-off. Like if the driver could permanently send his GPS location to you, that would be great. That would help with displaying it to the user. But the downside is, of course, that would use up a lot of data on his side, and that doesn't work, particularly not in every country where you don't have unlimited data and these kind of things. So you kind of have to do it in intervals. And then on the user side, you really you determine what the route would be using the routing algorithm. You draw that on the map, and then you just start moving that car along that route. So you pretend towards the user that you know where the car is at all times, and then 10 seconds later, you get another GPS position, and you're like, oh, good, it's on the route. It's good, it's fine, it's close enough. And then you slow down the thing a little bit, or make it a little bit faster to make up for the difference. Or if it's wrong, well, too bad. Then you have to recalculate, and then you have that bad user experience where the user goes, oh no, he's further away than we thought there are, right? And and for how to send that stuff in practice, there's kind of real-time publish subscribe systems that you can, something like a Pusher, to name the company a friend works for, that allow you to do these kind of things on a technical level, to push things up, to subscribe to them as a viewer and get that information across.
So the server would just, I guess also on like some kind of rate limited basis, send down the current location of the driver to the people who subscribe to it?
Yeah, exactly.
How about, follow-up question to that, because you mentioned...
Maybe I don't know how much time we have, and I had some other hands up, so maybe I'll also, any questions we can't answer, we do have the booth, and you can just come down and chat with us, and we'll answer all your questions in detail. So who else? You have, yeah.
So I was going to ask about offline caching. You also mentioned what kind of capabilities are there in Here's API data to keep things still while you're not connected to them?
Yeah. So he's talking about basically offline maps, making things work while you don't have a data connection. That's not necessarily something that's particularly useful for a ride-sharing application, because you kind of need to be online to see where the other person is. But our SDK does have a very, very nice offline maps feature. So basically, you download the entire map of a certain region, which for us is usually in the US, it's at the state level. For smaller countries, it's at the country level. For like really big cities, I was in Delhi this year, so that's the city is so big that the entire city just gets downloaded as a map. And these are usually a couple of 100 megabytes big. You can download them, and then pretty much everything I've just described still works. You can still search for places, you can still do geocoding, you can still do routing. The only things that don't work is like it won't take live traffic into account, because obviously that's live and you can't do that. But that's sort of a very nice feature of our Android SDK. For that, to go a little bit into advertising mode, we really have the coolest stuff. So if that's something you're interested in, I would just say, go to developer.here.com and check that out, because I think you would love it. Any other questions before they violently pull me off stage? And we can take your follow-up question at the booth if you like. Okay? Thank you so much for coming.